So we have like read the data, see the data type, check for the missing value. Then luckily we don't have any missing value. In case of missing value, we know how to impute it. Then we have see the univariate outliers for all the continuous variables. In case of outliers, if it is like above the Whisker, we need to push back to the 95th quartile, other than less than 5th quartile. Then if it is like continuous versus categorical, then we see the ANOVA or feature map. Categorical versus categorical, we see the chi-square or cross tabulation or vertical and horizontal bars to check the values. So once we done everything, now we need to specify the Python, that what are my independent variables, what is my dependent variables. So this is what we are doing here. Let's, if you open the data, this is what our data file. What we are saying is, from this x equal to data set of iloc location 3 to 13. So what I'm saying is 3 is basically this one. This is 0, 1, 2, 3. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up to 12 columns, take them as an input. That's called x. And y is basically this 13th column. That is this exit. So that's what we are specifying both input and output to the Python environment. That's what here we are doing. If I say x, how many variables we'll get? We'll get the, this is what we need to always check for. Are we really, representing correctly or not? If you say x, how many variables we are seeing? 12 variables we are seeing. So there is no dependent. Now, we already discussed that computers cannot work with the labels data. So we need to convert them into the numbers. For that, label encoder is there. Yesterday, we have discussed like label encoder. Label encoder is basically give the numbers for each column. But even though, let's say male 1, female 2, it has given, we cannot use that because male is 1, female 2 is not meaning. So we need to convert them into dummy variables. So that's what we are doing for all the categorical variables from the x. We need to convert them into dummy variables. What are all the object variables here? There categorical variable, we have geography and gender. Rest all, if you see, the number variable. So next what we need to do is basically we need to create the dummy variables for the all the categorical variables, and that's what we are doing. Geography is equal pd dot get underscore dummy dummies x of geography and drop first. That means what dummy variables will do, if you have 3 columns, it will give the two variables like x, y, z. X, if it is x, 1, 0. If it is y, 0, 1. If it is z, both become 0. So that's how it will create the dummy variables. So same variables we are doing, geography equal pd underscore get dot geography and true, and that's what it will be overwritten. And gender, basically we are creating the variable. That's what we are doing, gender variable. Then what we are trying to do, we are adding this new geography and gender dummy variables into our x. That is what our input data. That's what we have done. Now if I say x, so what we all get now? So this is what our geography female. What will happen as we say geography as the dummy variable and first as true, it basically excluded France. That means France is basically, if both are 0, 0, that is the France. That's how it will exclude. If it's Germany, 1, otherwise 0. If it is Spain, 1, otherwise 0. And both are 0 means that is France. That's how it does the dummy coding. And similarly, male is 0, female equal to 1. So that's what it does. Now this information is also there, this is also there. We need to remove this geography and gender because computers cannot understand this data. So we need to exclude this data and use this data. That's what we are doing here. We are just dropping those two variables. Now this is what your final x. So this is what your final input data, where you have credit score, age, tenure, balance, number of product, has credit card or not, is active member or not, estimated salary, whether the respondent belongs to Germany or Spain. If he is not of both, then that becomes treated as France. And if male 0, if it is female 1, otherwise male 0. That's how we need to, this is what our final input data. Now, before getting into the model, what we discussed that for the cross validation, for the better generalization capability, we always need to validate the model. We always need to validate the model on the test data and see the accuracy. And by doing this, we can validate the model, and we can also try test for the overfitting, underfitting. For that, we need to validate the model. So what I am doing here is basically I am creating 80% as train data and 20% as validation test. Validation, completely validation. So that's what I am doing. For that, I have a function in scikit-learn, that is train test script function is there, which is basically there from scikit model underscore selection framework. Isme I have this function. By using this function, I am splitting my train and test data 80 and 20% respectively. Okay. Now what I need to do is basically once I do this, here before going to the model, if I see credit score is number, age is number, tenure is number, we have different variables in the different units. So in order to compare this, in order to make the model more stable, we need to standardize the variables. So that means we need to put mean 0, standard deviation 1. So we need to standardize the variable. That's what I am doing here. From scikit-learn free processing stand scalar, I am basically converting all the variables mean 0 and standard deviation 1. By that, it cannot impact the, units effect. If you see extract, what will happen now? All your values will be, standardized. This credit score, age, tenure, everything will be standardized. Okay. Now, once I do this, what I need to do now? I have a train data and validation data. Now train data is standardized. Now I have a dependent variable, basically 10. Now I need to build the model. So these are the different functions which help you to build various pipelines of the machine learning models. I just import all the functions. Now what I am doing k-fold validation on the train data. What I'm trying to do, I'm basically taking the train data. I'm splitting the train data into 10-fold. Each time I will use one fold as train test and I will use, each time I will use 9 folds as training and 1 fold as test, and I will repeat this process on the train data to get the good accuracies. That's what I am doing here. So now, as I told you that we need to run the models in a pipeline. So as there is no freehand algorithm, here I have done one thing. Models, I am building a logistic regression because of the classification problem. I am doing a logistic regression, discriminant analysis, k nearest neighborhood, cart, regression trees, naive Bayesian, and support vector machines, add boost, random forest. So here if you see, I am using the logistic regression, which is the regression based approach. LDI is also regression based approach. K nearest neighborhood is instantaneous approach. CART is the decision tree rule based approach. Naive Bayesian is a probability based approach. SVM is basically layer based approach. Add boost is a boosting based approach. Random forest is a bagging based approach. As there is no freelance algorithm for the machine learning, what I am trying to do is I am trying to use all the models, and based on the results, I will select the best model. That's what I am doing here. So if you do this, oh sorry. Yeah, so that's what I am doing. Then I am basically running the model. I am putting all the results here. So results, names, if the result in this model, for each model it will iterate and it will give the results for both, validate for both train accuracies, train and test accuracy. If you see the, this is 80% accuracy LR on the train data and 80%. Basically, what it does is basically by using k-fold, it is basically giving the accuracy scores on the test score. That means on the train data, we have done the 10 folds. And each fold it basically take, then it will give the average out. So logistic regression is 80, discriminant is also 80%, k nearest neighborhood is 80, cart, all those. Now let's put in a chart and see. Because now if you see all these, I think the SVM still it is running actually, that's why. Because add boosting will take time. Boosting and bagging will take time. So we are running logistic regression, discriminant analysis, k nearest neighborhood, navigation, support vector missions, and all the methods we are running. On basis on the k-fold validation accuracy, we'll select one model and use that model on the test data and see how it is working. So now if you see all these models, so out of all these models, the random forest is basically giving around 87% of accuracy on the k-fold validation. So now what I am doing is basically, I am taking the random forest. Out of all this model, which model came as the best model? Random forest. Now I will take the random forest, and as a random forest, I told you there has been some parameters, some hyperparameters, number of trees, what is the method, how many variables we need to consider. So now what I will do, I will take the random forest method and I will run the model. When I am running the model also, I can't get the good results on the default parameter. So that's where I'm using the hyperparameters. Now from this pipeline, I somehow selected the random forest algorithm. Now this random forest algorithm I am choosing, and now I am trying to find the best combination of the parameters. That's what we discussed about the hyperparameter concept. So if you see the random forest algorithm itself, there will be three to four set of parameter default parameters are there. Number of estimators is basically how many number of trees I need to build. So here I am giving 100 or 300. What is the criteria for splitting the tree? Gini and entropy. I am saying use these two options. And bootstrap, use the data bootstrap and maximum features. So in a tree, how many features I need to consider? So these are the parameters. When you run the random forest, it will take the default and give. Now the default may not give the good accuracy. That's why I am doing the hyperparameter training. So I am giving all the parameters and running the grid search. Grid search, what it does is basically it will take 100 Gini true auto one model, 100 Gini false auto one model like 2, 4, 6, 8. It basically does how many models? 16 random forest models it internally runs, and based on that accuracy, it will give the best combination of the parameters. Let's see and see. I now I say it will take time. So if I please keep the mute here. It's like so many people are there. So what I am doing is basically here I am trying to find the best combination of the variables. Because it has to run so many combinations: 100 Gini true auto, 100 Gini false auto, 100 entropy true auto. Like that, it has to build so many random forests with the so many combination and try to see the validation. And from that, it will give the best configuration parameters. So what is the best number of trees? What is the best criteria? What is the features? Then we will take that model and finally build the model. That's what we'll do now. మేడం ఈ ఓయూ క్లాస్లో ఉన్నాను, నేను మళ్ళీ కాల్ బ్యాక్ చేస్తాను. ఓకే, ఆ డేటా నేను ఇవాళ వర్క్ చేసి పంపిస్తాను మేడం. అది మీరు పంపించారా స్లైడ్స్? ఆ 3 పంపించేసేయండి నాకు. ఏం మిస్ అయ్యాయి మేడం? ఏ ఎక్సెల్? ఓకే, మిస్ అయ్యాయి. మిస్ అయ్యాయి. ఓకే ఓకే ఓకే. ఇది నేను చేస్తాను మేడం ఈరోజు. Yeah, let it begin. Yeah, so what it does is basically it ran with all the combinations. With all these combinations, it has given the best parameters. So what is the best parameter? Bootstrap true, criterion is entropy, max features equal to auto, n estimate is equal to 300. So that's what grid search does. Grid search basically take all the combination, it will give the best combination. Now we will use this best combination and build the random forest. That's what I am doing here. What I am doing, the random forest classifier, bootstrap equal to true, criterion equal entropy, max features equal to true, auto karke I am just running the random forest algorithm. So once I run this algorithm, so now what I am doing, I first selected the random forest. With the random forest, I got the best parameters. Now with this best parameters, I ran the final model. Now I using this final model and trying to find the accuracy on the train. So how much accuracy I got on training data? It basically got 100% accuracy on the train data. Okay, but the problem is, random forest is a bagging method. So we cannot use the, I mean, if you are really trying to understand why the consumers are leaving, so random forest may not give the best answer. So but how we can use this random forest? We already discussed, as we are building multiple trees and keeping some variable aside, people aside, as we are building different trees, the random forest will give one of the best feature called the variable importance. So what I will do now, I will use this. This is the best model. Now I will use the variable importance from the random forest and use this variables through the logistic regression, because logistic regression is a simple model and it can also give the clear interpretation, because interpretation is also important. So that's what I am using the random forest. So I got key variables. If I say from the random forest, I got these are the key variables like age, estimated salary, balance, credit score, number of products. So now I will take age, estimated, balance, credit score, number of products. I can only take these 5 variables which came as a important variables from the random forest, but random forest may not give the interpretation. That's why I will take only these 5 variables and fit the logistic regression, because logistic regression is very useful to explain, very easy to explain. So that's what I am taking. I am taking only these variables. In X, in earlier X we have all the variables. We ran the pipeline, we find the random forest, and from the random forest we selected these are the variable top variables, because by criterion of good model it should be easy to apply, easy to use with the lesser number of variables. So now what we do, we somehow selected the key variables. Now we are using these key variables and building logistic regression, because logistic regression is a linear regression which can be explained very useful. So that's the reason I am using the logistic regression. Here also I standardize the data. Then I am just putting the logistic regression. In the logistic regression, basically I am fitting the logistic regression. I am 1 minute. Hello. So I am fitting a logistic regression, and I am testing on the training and testing and see the classification accuracy. I will explain in a second. Don't worry. So I am fitting on the logistic regression. Then once I use the logistic regression, I got 78% on the train data, 77% on the test data. That means it is not overfitting or either fitting. So now I can use this model for the future purpose. So now I have a model. So if I get the future, I just need to predict. I just need to say classify.predict and give the data. I will get the prediction. So what I am saying is, if you let's say prediction in the test data, because test data what you are applying, if I say prediction 1 for each respondent, you will get whether the respondent will churn or not. So that's what the typical machine learning framework look like. So this is what a typical classification problem. Any classification problem you take, first you need to read the data, you need to understand the data using descriptive statistics and visualization. Then you have to pre-process the data. Under pre-process the data, you have to impute the missing value, you have to impute the outliers, and you have to normalize or standardize the data. Then you need to train and split the data, use the trained data and run the pipeline of the machine learning and find the best model. So, but the problem is, because there have been a lot of variables. So what I will do, I need to select I cannot use all the variables. So I am using random forest is a method to select the variables. So what we are using is basically we are fitting the random forest, and we are through variable importance, we are finding the key variables and use that key variables in the logistic regression, and using the final equation through logistic regression. So that's what our machine learning pipeline. Read the data, build the model. In the higher level, we are building the logistic regression, sorry, random forest. In the random forest, we are trying to use random forest to eliminate some unimportant variables and find the key variables, use the key variables by using the logistic regression and fit the model. This is what our machine learning pipeline to solve the problem. So now whatever classification problem you work, you need to follow this method. Today what I will do, I will share this HTML straight away after this call. I will share this HTML file as well as this thesis, whatever this thesis is there now, last time the same thesis. Um, uh, so try to read this thesis, you will understand this final project mein churn modeling ka this is Python 5. So this PDF file straight away I will send it to you. What you guys, this is one of your seniors project. I just convert them into PDF and try to read this and try to understand this process. If you understand this process, what I will do, tomorrow I will assign some of the classification projects to some teams, and tomorrow we will discuss a regression problem in the same lines. Advainama? Hello? Hello?
Yes, sir.
So what I will do right now, I will share 1 minute.